This brief video is just to go over chemical versus structural formulae versus models that we use. Just want to make sure these things make sense. So on the left here you see a chemical formula, C2H6O. So a chemical formula just tells you the type, each element, and how many atoms of each element are present. So we know, for example, that this molecule has 2 atoms of carbon, 6 atoms of hydrogen, and 1 atom of oxygen. Now the chemical formula for an ionic compound is simply going to be the formula unit. And so even though a given sample of sodium chloride might have a billion sodium atoms and a billion chloride atoms, you still only see NaCl because that's just the ratio or the formula unit for that ionic compound. If it is a molecular compound, then you see all of the atoms that are present in a single molecule. Now to contrast that, the structural formula, so the chemical formula that's given there is a type of molecular formula. And sometimes when we see molecular formulae, we call them, they're sort of between a chemical formula and a structural formula. But we'll talk more about that in class. And so the structural formula that you see in the middle not only gives the identity and numbers of each atom, but it shows how they are connected to each other, which gives you more information than the chemical formula, of course. You see that the 2 carbon atoms are connected to each other through a single covalent bond. You see that 3 hydrogens are connected to the first carbon, that 2 hydrogens are connected to the second carbon, and that the oxygen is connected to the carbon and has its own attached hydrogen. So from this, you can kind of see the type of molecule. This is a type of alcohol. You know that because it has carbons in it and it has an OH group attached at one side. On the right-hand side is a molecular model. The molecular model shows you sort of the shape of that molecule. Now here, in the structural formula, you can see that there are 2 carbons, and that's why there's a subscript 2, and there are 1, 2, 3, 4, 5, 6 hydrogens, and that's why there's a 6 here. And there's 1 oxygen, which is shown here, and there's 1 oxygen here. But you don't know until you look at the structural formula that one of the hydrogens is connected to the oxygen. The 1 is usually left off of a chemical formula, it's just understood. Now here you can see the atoms have certain colors, the elements have certain colors associated with them. So the model actually gives you a little bit even more information. You can see that the carbons are shown in black, the hydrogens are white, and the oxygen is red. Not only do you see how they're connected to each other, but you can see the shape of the molecule as well. Carbon is almost always black or gray in a model. Hydrogen is almost always white or light gray, and oxygen is always red.